Okay, let's look at these next few examples. 104, 105, and 106 all ask us to do the same thing. Find the kernel of the linear transformation for the matrix. Okay, so formally what I'd do here on 104 is I would take this matrix A, I'd multiply it by x and set it equal to the 0 vector and then solve for x. So let's look at how to do that. Instead of writing it out like a matrix equation, I'm going to write it as a augmented matrix. 10, 5, 2, 4, 0. 6, 3, 2, 0, 0. Then I'm going to row reduce that. Now I've already put that into octave. If you look at this, when I row reduced it, it gave us 1, 1/2, 0, 1, 0. Then across the bottom, 0, 0, 1, negative 3, 0. All right, we've got to give these some names. So I'm going to call them X, Y, Z, W. Linear algebra is like the only place where W gets used after Z instead of before X, but it's just sort of traditionally what's done there. Of course, it doesn't really matter. Okay, so now I'm going to write up my general solution here. Let's see, Y and W are both free variables because they don't have a leading 1. So that top line is going to give me X equals minus 1/2 Y minus W. Then I'll get Y equals Y. Next up, Z. Second equation gives me Z equals 3W. And W equals W. Now, I'm going to show you two different ways to write out the kernel. The way that I tend to do it, I like to write it like this. We get X, Y, Z, W. The elements of the kernel are going to look like this. Get Y times minus 1/2, 1, 0, 0, plus W times negative 1, 0, 3, 1. So you could say that this is the kernel. If you wanted to, you could extract these two vectors here, this guy and this guy, and say those form a basis of the kernel. And that's just as good because it tells you how to generate all the vectors in the kernel. But the book does something a little different. They tend to put these things as they put it as like a point with S and T in it. Here's what they do. They take it and write it as they write it like this. X is going to be minus 1/2 Y minus W. Y is just Y. Z is 3W. And W is W. So the book tends to write their answers like that. And not only that, they go in and they replace the Y's and W's with S's and T's, which really makes no difference because all it's doing is renaming the vectors. But they'll write it out like this though. They'll say this where Y and W are real numbers, or any real numbers. So either one of those ways is perfectly acceptable for writing out your answer. It's just one way I'm writing it as a sum of two vectors, two basis vectors. The other way we're just taking these things over here and writing each one of them as the coordinates there. So both of those work perfectly fine. All right. My cat is down here, so I'll stop this video now.